Hey guys, it's Vince. Before I get into detail in this video, I just want to wish everybody a very happy and safe 4th of July and just remind everybody to give thanks to our local veterans, whether it be friends or family. Without them, this day just wouldn't be what it is. So I just want to start off by saying this video is definitely long overdue. I've been wanting to do this for some time, but of course, like everybody else, my time is limited, and I'm trying to give you guys as much information as simply as possible, because I know things can be really confusing, especially when we're setting up a new system or you're trying to digest everything between CAD/CAM software, Mach 3 motion control software. It can get really daunting. So what I've done is put together a basic graphics screen in my Vinyl Master software so I can cover with you real quick an understanding, or make you hopefully understand, how relays setup work in a G540 motion control system. So what you have here, I'm just going to break it down real quick. We've got a actual pinout snapshot from the G540's user's manual. This is available in the back of the user's manual. It's free to download. I recommend everybody who owns a G540 understand these diagrams backwards. If you're just now looking at getting one, I would tell you to start studying it now before you get your unit. And if you do have a box that you're looking at modifying to put a relay system in, this is something you're definitely going to want to pay close attention to. So what we're looking at here, I'm just going to cover it real quick. You got a Db9 Pin Out. The Db9 Pin Out is the allocation of the pin numbers on a Db9 connector used to actually connect your motor cables. Okay, so if you're actually soldering the Db9s that come with a standard G540, these are the connector configuration and the pin numbers allocated to them. If you go over here, this is the main terminal block of the G540. We all know, or should all know, pins 1 through 12. There's 12 terminals on the actual G540's terminal block. And over here is a Db9 Pin Out. This is the main stock communication cable between the G540 and your computer, the heart of the system. Okay, without this cable, no communication is being done, and therefore CNC is not CNC anymore. Okay, so overall, what are we looking at? On the left side, you can see I've got a snapshot from Mach 3, and it's the Output Signals tab under Ports and Pins. And what you have here is output number 1 and output number 2. Well, the G540, to let everybody know and make sure everybody's on the same page, has the availability of controlling 2 relays on its terminal block on pins 5 and 6. Pin 5 on the G540 terminal block supports output 1. Pin 6 supports output 2. Okay, but one of the things where it gets most confusing, when guys go to hook things up, they're thinking, I'm going to just hook up 5 and 6. They'll come over here to pin number and they'll go, okay, well, pin number, it's hooked up. 5 is pin number 1 for output, and then 6 is pin number 2. That's incorrect, and here is why it's incorrect. They're looking at this number over here. What they should be looking at is over here where it says output 1 Db9 pin 17. Now you can cross-reference this very simply by coming over here to pin number 17 and seeing output 1. Okay, and what this is basically telling you on this cross-reference, just as if you come over to pin number 6 on the terminal block of the G540, you could see Db9 is pin number 1 for output 2, and it is. What these numbers for the pin number are really asking you in Mach 3, and being Mach 3 is older, they could have done a lot better job explaining what really each actual allocation is. And in this case, pin number is identifying the Db9 pinout number, not the number of the terminal block that it's connected to, or the number of the G540's terminal block. So what you're realistically looking at here is the allocation to Db9, because the Db9, of course, is sending the signal from Mach 3 to your relays and to the G540. So what you want to do is configure your outputs using this configuration. So what we need to do, you can see here, output 1. If you match these settings, of course, in Mach 3 you're going to be set. But I want you guys not just to match them. I want you to understand what you're doing, because if you ever have to service your system yourself, the only way to truly digest what's going on is to understand the correlation between everything. So what you're seeing here, output number 1, you can see the green checkbox is enabled. Port number 1, what does port number signify? Signifies what driver system you're controlling in the main system. So in this situation, you don't have individual drives, you actually have a G540, which is an integrated 4-axis digital driver system. Therefore, that driver is allocated to port number 1 because that's the main communication port, or I should say the stock communication port in Mach 3. You would not mess with this number 98% of the time unless you had an additional driver system. Some guys can actually hook up 2 G540s in an expansion package. Again, 98% of you are not doing that. So realistically, when it comes to port number, this number typically does not change. What changes is the pin number allocation of the communication pin. What this could have been said or could have been rewritten into is the communication pin number. And in this instance, like I stated earlier, output number 1, if you go over here and you just go down to Db9 Pin Out, again, using the cross-reference terminal block pinouts from the G540 user manual, you can see 17, output number 1. So you can see then pin number 17. Output number 2, again, if you had 2 relays, you would click it on enabled. Port number, again, as we just covered, would stay on 1 because you only have 1 G540. And then over here, pin number would be 1. Why would it be 1? Once again, you can cross-reference over here, Db9 Pin Out. You can see pin number 1, output 2. Another way to cross-reference, very simple, is just come over here to the G540 user's manual pinout for the main terminal block of the G540. You can see 1 through 12. And once again, when you look at 5, output 1, Db9 pin 17, which we just configured. And then over here, pin number 6 on the G540 main terminal block is output number 2. And again, being its output number 2, you can see Db9 pin number 1. And there you go. Now again, if I have some guys, and I just want to make sure there's no confusion, if you only have 1 relay, you're not going to set up the output number 2 and vice versa. So again, setting this up, very, very simple. You can just look at my screen settings and you'd be set to go. However, you're not learning anything. So please watch the video. I'm taking the time to do this so you guys are empowered if you ever have to service your system. Now I'm going to get this stuff out of the way. Once again, I do highly recommend studying this terminal block configuration in the G540 user's manual at the back of the manual. Okay, if you're just getting a system, if you've got a system, if you're having me build a system, study this. It'll definitely save you some time if you ever want to service your own unit. Okay, I'm going to get this out of the way now. And now I'm going to get away the Mach 3 settings for the relays. What I want to discuss is the relay wiring and doing it correctly. Okay, a lot of guys I've seen online do this. There's a lot of different schematics for it, and I got to be honest, I haven't been very happy with what I've seen because mainly, yes, they work. It's how well they work and how consistent they work. What I'm trying to do is eliminate all of the possible issues when you set this system up. Okay, first I want to let you know that I've already designed a whole package that I'm about to release that will let you convert the G540 with relays. Very, very simple. It will include a toolless mounting package, all the required cabling, terminals, heat shrink, everything you'll need to complete this, just as you see here, including the terminal splitter. Okay, so right now I just made this simple, probably the easiest wiring diagram I could possibly come up with so everybody can understand exactly what's going on. You can see G540 outputs for relays are 5 and 6 on its terminal block. So again, I got the numbered terminal block here. You can see how simple that is. And of course, 5 and 6 are your relays. G540 output 1, 5, 6 is G540 output 2. Very simple. Relay you want to go with is a 48 volt 30 amp relay. Now I've been questioned about this numerous times. The voltage of the relay should always match the input voltage of the G540. Now the G540 doesn't require 48 volts. However, it is its maximum powered supply. You can actually go up to 50 volts. However, I don't recommend it because you're really not going to see any real difference with 2 volts in variance. On top of the fact that the drive just gets hotter, there's really no benefit. That being said, 48 volt 30 amp is really the best way to go. Single pole, single throw, SPST. I'm not going to get into the electrical engineering side of it, but realistically, this is really what you're looking for, 48 volt 30 amp relay. And again, hooking it up could not be simpler. All relays, and I'm going to just zoom in here real quick because these pictures are really good in detail. Let me just see here. If you zoom in enough, you can see this says NO right there. I'm hoping you can see it because I can see it. And then over here it says COM. Okay, but it being that the casing is actually black, it makes it difficult to see. So I made it in green so you guys can understand exactly what's going on here. Okay, as far as wiring the unit, of course, the G540 gets wired on its first output from pin 5. So pin 5 would come over here. You would simply turn the relay you purchased from me to match the configuration it's in here. Again, it wouldn't be vertical, it'd be horizontal, and you want to make sure that all these plugs are matched to this picture and simply wire it this way. So again, you'd have your output wire coming from pin 5 for output 1, and then from the red actually going to a terminal splitter, which the red would signify a positive, and a positive being from the power supply. You can see our power supply here, and again, whatever 48 volt or whatever power supply you're using, that would be the required rating of voltage of the relay being used. I've had guys try to use everything from 19 volt to 32 volt, then they get hung up on, is it mechanical, is it solid state? It doesn't matter. Really, what really matters is the fact I like simple, and keeping things simple will make you two things: servicing the system, I always bring this up, and assembling the system. This configuration, without a doubt, is the easiest configuration you will get for a couple different reasons. I'm going to cover it real quick. Using a terminal splitter, you can see exactly what I did here. You're splitting your power lead, or one of your power leads. That power lead is going to 11 because on the G540, power input is pin number 11. Once you split that power lead from a terminal block, you're then going to use these additional two splits to go to the actual power driving your relays. Now again, if you only had one output, of course this secondary relay wouldn't be there. However, for the guys that want to run two, that relay would be there, and therefore you could see how easy the terminal block makes it, or the terminal splitter I should say makes it, to configure your system easily. You're not going to be fighting over wiring, multiple terminals on the actual power supply, which most of them only support one terminal anyways. And on top of that, and this I cannot emphasize enough, you're not daisy chaining, guys. That means if this relay goes, you can identify it went without having you see two relays giving you problems. Okay, you don't want to ever connect two wires from two separate subassemblies together. Remember, each relay, and I've spoken about this before, it requires its own subassembly, or is its own subassembly, meaning that this relay will be controlling a separate peripheral as well as this relay. Okay, typically you're not going to have two relays controlling the same exact peripheral. So if this relay, if output 1 relay goes, you want to be able to identify it quick, get it changed, and get your system back up and functioning so you can produce product. Right now, what you see here, this is the easiest configuration to identify a problem. And why is that? You got your G540 right here splitting the power. If one of these relays fail, you can instantly see it and correct the situation. That being said, I've had guys do all kinds of configurations where they wire in both relays together, they daisy chain. You don't want to do that. I know guys try to save money, but I don't know how everybody values their time. I value mine highly because I know that when you're doing things smart and you do things right the first time, it will pay you high dividends in the backwards motion of things, so to speak. When all of a sudden the problem arises, you already know, hey, I did this right, I can fix this in 2 seconds, and you're good. The extra time, the extra money pays for itself in less problems. When you're sitting there trying to troubleshoot a system like this, when you have multiple connections, it gets to be a headache. That's why if you notice this diagram, there's a couple of them out online, and I'm sure you've seen most of them. They're busy as hell. This is simple. I mean, this is about as simple as you're going to get, and that is exactly what I wanted. I want you guys to see just how easy this is, as long as you really keep that subassembly in your mind of, okay, I'm going to make things real easy, not only to hook up, but also to troubleshoot, because it's always one and the same. If it's easy to hook up, it's easy to troubleshoot. And in this case, if this relay fails, you're still going to get power to the G540. Nothing is going to fail with the G540 because the terminal block is still supplying power. Okay? It's just a bridge of all of your power coming from your power supply. And it's the same thing with output number 2. If let's say relay number 2 fails and output number 1 is working, you would know right away because you would not be actually seeing any switch being turned on from output number 2. Therefore, if output 1 is working, power supply is working, G540 is working, you know that relay is bad. So you've already troubleshooted it on just looking at it, you're good to go. The system that I've just built, the package I should say, will include toolless mounts, like I said, all of the connectors, all of the required cable. I'm going to cover that real quick right now, and this will all be done in another video. But needless to say, The cable that I recommend when using relays should always be, at minimum, shielded, at the very minimum. Anything you do with signal manipulation with any type of CNC controller should always be shielded. That being said, for optimal control and making the signals bulletproof, I highly recommend double shielded cable in this kind of situation. Why? Some of my guys go out there and buy these, they build the system themselves, and they build it for more or less a plasma system. And once they get into the plasma design, plasmas, and I've said this numerous times, but I still get lots of questions on it, plasma systems are hell when it comes to EMI. They generate the most EMI, and when you're trying to switch your torch on, you want to make sure you have a bulletproof, and I mean bulletproof signal going to that torch. When that torch fires, the amount of EMI in the air is massive. So you need to always look at what you're dealing with. A lot of guys don't, I mean, I've never even seen another vendor carry double shielded cable. I do it for a reason, because I know it works. My double shielded spindle cable, you'll never have a problem with if it's grounded properly on its drain, nor will you have a problem with this kit if you utilize it to its full potential, and that's really what I'm looking at doing. I want you guys to have the best solution to an age-old problem, which, again, it varies with every system. Some guys can get away with standard shielded cable. Some guys have more luck with the double shield. Actually, I don't know anybody who doesn't have luck with the double shield. That's why I did it. I figured, why not just do it the right way the first time? Is it going to be the cheapest kit? It will be the most reasonable kit you can imagine for what it's including, because if you look at this setup right here, it really doesn't get any easier than that. Okay? And again, I do recommend using ring terminals. And when I say ring terminals, guys, on all of my terminal blocks, you have the option to either slide a wire in, tin it, and then lock it down with the screw, or you could actually use a ring terminal, which the screw would actually go through the center of the ring terminal, locking it. I highly recommend, and I cannot emphasize this enough, for safety, always, if possible, use a ring terminal that actually goes through or the actual screw that goes into the terminal block goes through the center of the ring terminal, so therefore it locks itself in to this terminal block. Therefore, it can never come undone on accident and ground out on the chassis, possibly causing a fire. A lot of guys don't think about this stuff. They think, oh, you know, it's just a terminal block, it's 48 volts, no big deal. Fires start all the time. Always prepare for the worst and hope for the best. So I always say do it that way. You'll never have any problems. Again, safety always first, and then simplicity. Okay, so right now you can see just how easy it is to set these up. I just covered the Mach 3 settings. If you guys do it this way, and again, at the very least, and I cannot emphasize this enough, make sure to use the shielded cable, preferably double shielded like I just covered. One thing about these relays, just to cover that real quick, they do require quick connection. You cannot solder inside these holes. I'll zoom in a little more. You can see that this is all boxed in, so there's no way you can get a good solder clip. However, the quick connects, I do recommend using solder on. Now, I have guys that'll argue with me left and right. You don't need to do that. You can use crimp connection. You do whatever you choose. I'm telling you, a solder connection done right will last a lifetime. I've had crimp connectors fail. I'm not a big believer in the insulated crimp connectors. I like doing heat shrink the old way because I know it's done right. If I handled it, it's done right. Hopefully you guys have the same outcome, especially considering, I always look at it this way, what am I going to be lazy with 8 connectors? You know, you're only going to have 8 connectors here. So what am I going to be lazy with? And why I say 8 connectors is if I'm doing 2 relays. If I'm only doing 1, I only have 4 connectors. So why am I going to be lazy? If I do the heat shrink and I do the soldering and I know I did it right, I don't have to go back and double check my work. It's done right and it'll last a lifetime. So again, think about that as you go. Again, you can see I did label everything normal, open, and calm, so you can hook up whatever peripherals you're hooking up. Very, very simple. And you can go through there and check and see, and you're set. I mean, this is a really quick schematic. Hopefully it's helped you guys. And again, if you just needed the Mach 3 settings, I already brought them up. You can go back to the beginning of the video and go over that. But I just wanted you guys to see the proper way, not only to set them up, not only to understand the configuration and the application in the allocation in Mach 3, but also understand the proper wiring sequence. You never, and I cannot emphasize this enough, you never want to wire or daisy chain relays. You never want to use standard wiring with relays. When you use a shielded cable on each individual relay, or if, now there are, I'll rephrase that, if you do decide to use 4-lead shielded cable, if you're doing 2 relays, because you got, again, you're going to have 2 leads here, 2 leads here, you can do that fine, okay? Pending, of course, you have your ground drain, where you're only going to have 1 drain going to the chassis that you're in, so that you'll be able to naturally go in there and make sure that that drain is actually grounding out properly. If you do not connect the drain from that shield, you will still be generating EMI because there's no way to dissipate it. So please understand there is more to this than just connecting wires. A lot of times these schematics online, they just show you the wiring just like this, and guys assume I can just use any wire, and then all of a sudden and 9 out of 10 of them, they're using a plasma system and then wonder why the hell the system is acting up. That's why. So again, do it right the first time and you'll be set. Once again, I will have the kit available. And my kit, again, I will include 1 relay if you need to. Of course, it'll be customizable. So consider this part 1 of the series. Once I get the kit ready to be listed, should be within this week, I will get it out. And the wiring diagram, this wiring diagram will be posted with it to keep everything simple, as well as the Mach 3 settings. And again, I hope this video has helped you guys at least take second thoughts on exactly configuring your system if you haven't done it already. And if you are adding a relay or looking at it, now you understand, you know, the right way to go about doing it, and at least seeing it visually, in the sense that if you had to service something, it's right there. If you have everything daisy chain, and a lot of guys don't think like that, that's why terminal splitters are so helpful in the system, especially if you do it right and allocate them properly. You can go in and service your system virtually endlessly and in seconds. So it makes things much, much easier. Again, my name is Vince. I'm over at eDealers Direct Automation. They did cut off the automation in my eBay store. If you need to contact me, again, my email is storm, STORM 2313 @gmail.com. And if you don't want to do that, you can always message me through eBay or YouTube, and I'll get right back to you. Thank you again, and guys, have a great 4th. Take care.